Right, this video is about matchings, and figure 1 shows a bipartite graph. It's got two sets of nodes, and arcs are connecting nodes from different sets, but never connect nodes in the same set. Let's just see what this means. What we've got is 6 people: Alison, Bertie, Charlie, Deirdre, Enid and Frida, and they can do six tasks, 1, 2, 3, 4, 5, 6. So Alison is very able to do task 3, and she's very happy to do task 5, but she really hates task 1 or task 2 or task 4 or task 6. Bertie will only do task 3, and so on. So the idea is to allocate these 6 people to these 6 tasks, and what we have at the moment is a matching. If we manage to get every person here doing one task or another, that would be a complete matching. Now, part B indicates that in this example it's not possible to find a complete matching. But part A asks us to use this initial matching, so Alison doing task 3, Charlie doing task 2, Deirdre doing task 1, Enid doing task 6. Using that initial matching, use the maximum matching algorithm to find an improved matching. So let's get going on that. So the way to do an improved matching is to start with somebody who has no task allocated to them and see what task they could do. So I'm going to start with person B, with Bertie, and Bertie could do task 3. But who is doing task 3 at the moment? Task 3 is currently being done by Alison. So 3 is currently Alison A. I'm making these names up, it doesn't say Alison, I'm just making them up. So what could Alison do? Well, Alison, instead of doing task 3, could do task 5. And actually task 5 is one that in the initial matching has no problem doing it. So now we've got an improved matching. And the way we can show the improved matching is to replace the minus signs by equal signs and vice versa. Now, writing those two lines down, both lines, is important to get full marks in the exam. This is what the method marks are for. So Bertie could have done 3, which was currently being done by Alison, who could do task 5. So now we've got that. The question says you should list the alternating path, that's this, and then you should list your improved matching. So the improved matching is that person A is doing 5, person B is doing 3, and then you need to put the rest in. Person C is doing 2, person D is doing 1, E is doing 6, and F is unmatched, and you need to write this down. You need to write down that F is unmatched. So that's part A done. Part B says explain why it's not possible to find a complete matching. And there's 2 reasons you could give. One is that person C is the only person that can do 2 and the only person that can do 4. So that would be a good answer. Another answer, you don't have to give both, is that D, E and F between them can only be allocated to 1 and 6. So D, E and F can only go to 1 or 6. There's 3 people but only 2 activities. So you could write this as an alternative answer. So that would do. That's 2 tasks, that says there. Okay, so that's part B done. Now part C, D now has task 2 added to their possible allocation. So there I filled that in red there. And using the improved matching found in part A, so I've drawn that out here. This is the improved matching found in part A. Use the maximum matching algorithm to find a complete matching. And we must do the same thing. We must list the alternating path and the complete matching. So as before, I'm going to start with the person who has nothing allocated to them. That's person F. And what could person F do? Well, person F could do task 6. That's shown here. So in here, person F has nothing allocated to them, but they could do task 6. So I'm going to start with person F. At the moment, 6 is allocated to E. Remember that we're looking at the improved matching to do this. So it's this bit here, 6 goes to E. But what could person E do? If we go back to this diagram here, E is doing 6, but E could do 1 instead. So let's say E is 1. Who's currently doing 1? D is. What could D do? D could do 2. That's our improved area. Who's doing 2 at the moment? C. What could C do? C could do 4. Oh, that's it. We're finished because we've now got to a stage where we've got task 4 allocated to someone. So now we go through this again, and then we replace all the minuses with equals and all the equals with minuses. So it sounds a bit trivial, but this is the most important part because this shows us the solution. And then the final, we need to list the complete matching. So person A is still doing 5. B is still doing 3. C is now doing 4. D is now doing 2. E is now doing 1. And F is now doing 6. So that's the complete matching.